Welcome to the next tutorial on electricity. In this tutorial, we will be discussing how the current flows when the resistances are connected in series. Now, this is how the circuit, how we draw when we draw two resistances in series, and in the green we showed how to draw three resistances when they are connected in series. Of course, we discussed this in the earlier tutorial. In this tutorial, our focus will be how to calculate the total resistance, which is also called resultant resistance, when multiple resistances are connected in series. So, our point of discussion is what is the net resistance, also called resultant resistance. So, this is a new term which you should remember. This is called resultant. This may not be always the sum of the resistances. Sometimes it could be, sometimes it may not be. So, what is the net resistance, also called resultant resistance, when more than one resistances are connected in series, when multiple resistances are connected in series. This is what we will be discussing in this tutorial. There are few facts that we need to know. There are few facts that you need to know, based on which we will be discussing the properties of this electric circuit. Number one, the potential difference across each end of a resistance depends on the value of each resistance. So, let us examine what this statement really means. Suppose there are two resistances, R1 and R2, and these two resistances are connected in series. This is the battery, and with a voltage of V. This voltage V will remain the same for this battery. So, we will assume that V remains the same. Now, in that case, what is the potential difference across the resistance R1? This is how it shows. This, if the potential difference across the resistance R1, suppose if we connect a voltmeter across R1, then what will be the voltmeter reading? That is called the potential difference across R1. This potential difference across R1, that is V1, will depend on the value of R1. This is most important thing. So, the potential difference across the resistance, across a resistance which is connected in series, will depend on the value of that resistance. So, this is one important thing that you should remember, should understand, that when multiple resistances are connected in series, the potential difference across a resistance will depend on the value of that resistance, and we will examine this in more detail. Now, second fact that you should remember, potential difference across all the resistances is equal to the voltage of the battery. Now, let us examine this point also. Let me pull a new board. Now, suppose there are two resistances R1 and R2, just like the previous diagram. This is how the electric circuit looks like. Now, here we mean what is the potential difference across all the resistances. That means potential difference across the point, between the point A and C. Now we are not talking about individual resistances, we are talking about the combination of resistances. So what is the potential difference across the points AC? This will be same as V, which is the voltage of the battery. Of course it has to be, because the same battery supplies current, supplies voltage to all the resistances. So this is what this second point means. Third point, same amount of current flows through each resistance. Let us examine this point also. Suppose the current flow is I. That means since the resistances are connected in series, there is only one way for it to go. So the same current I will flow through R1, same current I ampere will flow through R2. So if I is the current flow, that is rate of flow of current, then I ampere current will flow through both R1 and R2. So the potential difference across the resistances are different, but same current, same rate of current will flow through each resistance. So these are the three facts we should try to understand, and based on that we will be doing some more studies on the properties of resistances when they are connected in series. And this is also true not only for two resistances, for any number of resistances when they are connected in series. So whatever is true for two resistances in series, same is true for any number of resistances when they are connected in series. So starting from next tutorial, we will discuss how to calculate the potential difference across individual resistances